So the next step is the minimum reinforcement check as per ACI, that if you are using the grade 60 steel, so the equation for the minimum is 0.002 into AG, and if the reinforcement is less than 60, this is, and if it is equal to or greater than 60 grade steel, then the two equations should be satisfied for the minimum reinforcement, right? So we are using normally in Pakistan or all around the world, the normal grade is 60, but in other country, the 70 grade or 90 grade steel has already been used, but in Pakistan, normally this grade steel is used. For this, these two equations should be satisfied to provide the minimum reinforcement in the foundation, right? So in our case, the H we have selected, that is 18 inches. So it becomes the first equation is 0.0018 60 by 60. So these two will be cancelled, right? So there's no need to write in here. So here you can write the H into 18, 0.0018 into H, and into 12. 12 means one strip, so we'll get the reinforcement in inch square per foot, right? If I remove this, so the equation will become like this. So you have to multiply only the 0.0018 into 12 into ATAR, right? So it is 0.0018, right? And into 12 into 18. So this is the value 0.388. We will take 0.39. So we will write 0.39 inch square per foot, right? So this is the value from the equation 1, and the next one is 0.0014 into AG. So it will become 0.0014 into 12. This is per strip, and 12 means we are converting 1 foot into inches. That is why we are writing 12, and this is 18 inches. So it comes out to be 0.3. So this is the governing. This is the 0.3 inch square per foot, right? So this is the governing, that if the reinforcement given by the SAFE or ETAB is less than this, so you have to provide this much reinforcement in your footing, right? So this is the way how you will satisfy the ACI code. First, you have to check the minimum, and then again, you have to go towards the SAFE and check your reinforcement. Before going to the reinforcement, there is another check of uplifting. Uplifting means I've already explained in the previous one that this corner is in tension and this is in compression, which you do not want. All you have to go to the display and click on this show reaction forces, right? And click on the service load combo and click on the soil pressure and click on apply, right? So you can see on the left corner that the maximum displacement or the maximum pressure is 0, right? So there is no tension, and the minimum is minus. Minus means compression, and maximum, the plus means tension. So there is no uplifting or tension in our footing, so we are on the safe side. So if this happens, for example, in this footing, if this corner is in compression and this is in tension, then you have to provide the strap beam or increase the width of the footing, and you have to play with these parameters to overcome this problem, right? So in our case, there is no problem, but if this happens, then you have to provide the strap beam and you have to increase the thickness to convert this tension into compression. So now you have to go to the design of the footing for the reinforcement. You have to go for the display and click on this slab design, which is, you can also use this shift plus F9 command. So this window will appear, right? So this is the finite element based design, in which if I click on this none and apply, so now it is showing me the reinforcement for the footing, right? And there is a section in the code that you have to check the reinforcement at the face of the column, not under the column, right? So for example, this is the point of the column. So you have to see the parameters. For example, we have 12 cross 12. So this is the X14. So you have to go for the 13.5. So this much for 0.5 inch square per foot reinforcement you should provide for this footing, right? So you can go to the Excel sheet, and we have this much reinforcement, which is 0.51 inch square per foot reinforcement. So if you use number 4 bar, or you can use number 6 bar, for example, if I use number 6 bar, its area is 0.44. So you have to divide it with the AS value, and then you have to multiply this with 12. You will get the spacing for the reinforcement. If you use number 6 bar at the rate 10 inch center, so it will work, right? So let us go again to the safe. So this is how you will calculate manually. For example, if I go to this portion, it is asking me about 0.1, 0.14. So if I use, so this is 0.14 inch square per foot. So if I use number 4 bar, in the area of number 4 is 0.2 inch square. So divide that by the required area of the steel, and then multiply with the 12, right? So if you provide number 4 bar at the rate 17 inch center, so it will work, right? So this is how you will provide the reinforcement manually. So there is another option in the ETAB, so you can also impose the minimum reinforcement as per the code, right? So now we have calculated previously the using manual calculation that the minimum reinforcement as per the ACI code is 0.39. So now if you uncheck this, so it will show you the required reinforcement. This is not the minimum reinforcement. So if you provide this much reinforcement, the structure will stand and you are on the safe side. But you have to fulfill the ACI minimum requirement, which is this one, these two equations, and we have manually calculated it is 0.39. So if you click on this impose minimum reinforcement and click on apply, and if you see that this footing is working with the minimum reinforcement, it is come out to be 0.3888, which we calculated previously, and this is the value, right? So this is how you can check manually with the code or with the software, and this will develop your confidence that the software are working very efficiently and very perfectly, right? And you have seen that we have calculated the minimum reinforcement and it's come out to be 0.39, and it's also giving me 0.39 if I click on this impose minimum reinforcement, right? So if someone is confusing and if you want to check it manually, so it is just you are wasting your time, because this software has been developed very accurately and it is working very efficiently, right? So I have clicked on this minimum reinforcement. So the minimum reinforcement is 0.5 for this, because there is an earthquake force is included in this. So now this minimum reinforcement topic has been covered. Now we have to finalize the reinforcement for this footing. So there is another option. If you click on the typical reinforcement specified below, so I'm asking, I'm telling the software, if I provide this much reinforcement, for example, number 6 bar at the rate 12%, if I provide, so will it work or not? So you have to apply this. So this is the contours, and you can see that the contours has been reduced in some of the cases, that you can provide number 6 bar in this footing at the rate 12% in this, and here it again asking about some of the reinforcements. If I reduce the spacing, so now you can see the contours has been reduced or removed. This is the one direction. Direction 2 means in the Y direction, and direction 1 means in the X direction. So you have to check in the both direction, right? So in direction 1, in the X direction, the number 6 bar at the rate 9% is working for us in the interior column, but is not working in the exterior column. So if I go to the number 6, so now you can see that the reinforcement are okay for the interior as well as the exterior, but sometimes you can ignore this much reinforcement, because this is the non-linear analysis, it is done. But if you do the different projects, so then you have enough experience that this much reinforcement will work and this will not, right? So in the other direction, direction 2, still there is some reinforcement required by this footing. So we will select number 6 bar at the rate 6 centimeters for all the footing for the bottom, and we can decrease the spacing for the outer footing by applying it. So now you can see that the reinforcement has been disappeared and now showing 0, that if you provide number 6 at the rate 3 centimeters, so it will work, right? So we will provide number 6 at the rate 6 centimeters in both direction, in positive direction, in direction 1 and direction 2, and you can also provide number 6 at the rate 3 centimeters for the outer footing, right? So now let's go towards the top footing, and if I provide number 6 bar at the rate 12, so will it work? So now you can see that the direction in top in what direction, and this is direction 2 in other direction, right? So number 6 at the rate 6 centimeters in the both direction is working for the interior and for some of the exterior, but it's not working for the exterior in the exterior footing for this direction, because there may be unbalanced moment due to earthquake forces, right? So again, you can provide it with number 3. This is number 6 at the rate 6 centimeters. So now this will disappear, right? So you have to play with these values to make your structure economical. You have to go for number 4 if it is working with number 4 at the 6 centimeters, it's not working, but all our other members footings are okay with this number 4 at the rate 6 centimeters. But if I click on the none, whether it is requiring any reinforcement for the top reinforcement for the interior column or not, you can see it is asking me some portion, but not too much as compared to exterior, because these are the concentric columns, but the reinforcement is asking is due to the unbalanced coming from the earthquake, right? So for the top, we will provide number 4 bar at the rate 6 centimeters for other, and for the external in this portion we will provide number 4 bar at the rate 3 centimeters should work, right? So it is working, right? So this is how the results we concluded that for the bottom interior, right? For the bottom interior, we will use number 6 bar at the rate 6 inches center to center, right? These are for the interior in both the direction. You can also play with the reinforcement, as I have told you, that to make it economize, and how you do that I have just shown you. And for the bottom exterior, we have selected that we will use number 6 bar at the rate 3 inches center to center, right? And this is because there will be too much unbalanced moment coming from the earthquake forces, right? If you do not import the earthquake forces from ETAB, so it will show you only the bottom reinforcement, not the top reinforcement for the interior, which is not good for the design practice, right? So for the top, we have selected we will use number 4 bar at the rate 6 inches center to center. This is for the interior, and this is also fulfilling the minimum requirements as well, right? And for the top, we'll use number 4 at the rate 3 inches center. So you can this is for the exterior 3 and 4. We will specify in the final drafting or the submission drawings, right? So I will recommend you not to use spacing less than 3 inches for numbers up to number 6 bar. If the bar sizes is you are using number 8 bars, so you cannot use number 3 bars, right? You have to use number 4 bar, number 4 inch spacing minimum, right? So we are using number 6. So if you are using number 8 bar, so the minimum spacing should be 4 inches. So here we are using number 6, so we can use 3 inch center to center, right? So you have to keep all of these factors for the practical purpose as well. If you provide number 8 bars at the rate 2 inches, which is not practical possible because the dia of the number 8 bar is 1 inch and 1 inch, so there will be only 1 inch space left in between the two bars, and you cannot cast the pour the concrete inside the bars. So this was the whole story about the design of the isolated footing using the safe and ETAB. So again, just like we did for the minimum reinforcement, there is a check for the maximum spacing of the footing as per the ACI, that the ACI 31814 limits the maximum reinforcement spacing for two-way slab is defined in table 8.7.2, right? So this is not the table, this is the section. And this is the section for the non-pre-stressed solid slab maximum spacing defined by longitudinal should be lesser of 2h. And in our case, h is 18. So the 2h will become 18 into 2, that is 36 inches center to center, right? So this is the maximum limit, and the other limit is 18 inches, the lesser of these two, right? So this is the critical section, and 3h is on the other section other than the critical section, means that at the below the columns or below the walls, it is asking about this space. So the maximum limit of ACI is 18 inches and 36 inches. What we have provided is 3 inches and 6 inches. So this requirement has already been fulfilled, right? So this was the whole story about the design of isolated footing using ETABs and SAFE, how you can define your model your footing and then exporting it, and then punching check and uplifting, and then how you calculate the manually reinforcement, and you can use this command to provide the reinforcement and check with the limits are within the limits of ACI or not, right? So this is the end of this session of design of isolated footing using SAFE and ETAB. So now this there is any questions, तो आपको कोई क्वेश्चन है तो आप पूछ सकते हैं।
सर आपने जो अभी डिवाइड शेयर किया था स्लैब में, तो ये सर मैशिंग होती है या फिर क्या?
नहीं जी, ये आपके पास मैशिंग नहीं होती। मैशिंग तो आपके पास इंटरनली ये टैब और सेफ जो लेटेस्ट वर्जन है वो ऑटोमेटिकली कर लेते हैं। ये आपके पास एक्सटर्नल डिवीजन होती है, right? For example, if I click on this, so I want to divide this shell externally, right? आपके पास meshing जो होती है वो आपके पास internal meshing होती है, और ये आपके पास external division होती है। You have to divide this mesh externally, right? So if I divide it, for example, 4 by 3 by 2, it will divide this area externally in this division. So now you can delete as well, and you can play with these shells as well.
Okay.
जी शौकत
सर, आपने जो इसमें डिफाइन किया था वो स्लैब सेक्शन इस फाउंडेशन, तो सेफ में असल में एक ऑप्शन और भी होता है, वहाँ पे हम फुटिंग सेलेक्ट कर सकते हैं वहां से।
जी आपके पास वो आप फुटिंग भी सेलेक्ट कर सकते हैं। मैं स्लैब प्रॉपर्टीज में जाता हूँ, न्यू, आपके पास स्लैब भी है, या आपके पास फुटिंग भी है, या आपके पास मेट भी है, राइट? तो आपने एसीआई का जो इक्वेशन है आपको सेक्शन शो किया कि आपके पास जो फुटिंग्स होती है दैट आर डिजाइन एज अ टू वे स्लैब। अगर आप इसमें फुटिंग अगर आप सेलेक्ट कर ले या इसमें आप स्लैब सेलेक्ट कर ले, तो जो सॉफ्टवेयर है ऑटोमेटिकली वो आपके पास उसके लिए वो डिज़ाइन कर लेते हैं। स्लैब भी एस पर एसीआई वो डिज़ाइन कर लेते हैं, और आपके पास फुटिंग वो नेट है वो भी एस पर भी एसीआई उसको डिज़ाइन कर लेते हैं। अगर आप इसमें स्लैब सेलेक्ट कर ले या फुटिंग सेलेक्ट कर ले, सो देयर विल बी नो डिफरेंस इन डिज़ाइन में कोई फर्क नहीं पड़ेगा।
सर, और सेकंडली इसमें रिइंफोर्समेंट काफी हाई आ चुका है, मतलब नंबर 6 बार्स जो मैंने ज्यादातर देखे हैं सर, ज्यादातर नंबर 4 ही यूज करते हैं 2 स्टोरी के लिए।
एक्चुअली इसकी ग्रिड साइज ज्यादा है ना, वो ग्रिड साइज पे डिपेंड करती है। ये जो मैंने एग्जांपल हमने उठाया इसमें ग्रिड साइज काफी ज्यादा है। ये देखिए आपके पास एक साइड पे 12 है, दूसरी साइड पे आपके पास 14 है। और इसके लिए आपके पास मेरे ख्याल में ये जोन 3 के लिए भी हमने डिजाइन किया, तो उसमें आपके पास जो आर्थिक फोर्स अनबैलेंस मोमेंट है तो उसमें काफी ज्यादा आ रही है।
ठीक है सर, थैंक यू सर।
नॉर्मली आपके पास जो जोन 3 और जोन 2 भी के लिए तो आपके पास आइसोलेटेड फुटिंग में काफी कम रेनफोर्समेंट आएगी, लेकिन उसके लिए फिर हम कंबाइंड फुटिंग या स्टेप फुटिंग यूज करते हैं कि इस तरह के सारे जो फॉर एग्जांपल इफ आई शो यू, ये जो इस तरह हम फुटिंग प्रोवाइड करते हैं तो उसमें आपके पास फिर नंबर 4 बार आपके पास यूज होते हैं फॉर 2 स्टोरीज और 3 स्टोरीज। लेकिन फॉर द डेमोन्स्ट्रेशन पर्पस एंड फॉर द course I have used this 2 story in zone 3, and I just show you the process how you can design your reinforcement as per the requirement.
ठीक है सर। और ये स्ट्रिप फुटिंग में सर मैंने पूछा भी था ग्रुप में, आपने कहा कि लेक्चर के दौरान पूछ ले।
आपने क्या पूछा था कि स्ट्रिप फुटिंग में क्या फर्क है, वॉल फुटिंग में क्या फर्क है? आपने ये क्वेश्चन पूछा था कि स्ट्रिप फुटिंग वॉल फुटिंग में क्या फर्क है?
स्ट्रिप फुटिंग और सर कंबाइन फुटिंग।
अच्छा, देखिए फॉर एग्जांपल आपके पास एक फुटिंग आ रही है, फॉर एग्जांपल दीज टू, ये आपके पास 2 कॉलम्स हैं, राइट। अगर मैं इन दोनों कॉलम को इस तरह की फुटिंग प्रोवाइड कर लूँ, दिस इज कॉल्ड द कंबाइंड फुटिंग, राइट। लेकिन मैं अगर इस दोनों की फुटिंग भी इस तरह लेकर जाऊं और इन सारे जो कंबाइंड फुटिंग को मैं सारे को कंबाइन करके एक ही कंसिडर करके डिजाइन कर लूँ, सो इट विल बिकम दिस स्ट्रिप फुटिंग। लेकिन फॉर एग्जांपल दरमियान में मेरे साथ इसकी ज़रूरत नहीं है, तो मैं ओनली इनके साथ काम कर सकता हूँ, इनके साथ काम कर सकता हूँ। सो अगर आप इनको कंबाइन ना करें, सो इट विल बी कंबाइंड फुटिंग। अगर आप इस सारे कंबाइंड फुटिंग को कंबाइन कर लें, सो इट विल बिकम स्ट्रिप फुटिंग। स्ट्रिप फुटिंग आपके पास कॉलम जो वॉल फुटिंग आपके पास होती है वो आपके पास
आप जय
जी
ठीक है सर, ठीक है, थैंक यू।
जी हाकिम।
सर इस एग्जांपल में हमने आइसोलेटेड फुटिंग क्यों दी है?
जी
हमने आइसोलेटेड फुटिंग क्यों सेलेक्ट की है?
हमने क्यों सेलेक्ट किए?
हाँ मतलब जो हमारी सिलेक्शन क्राइटेरिया है, जैसे कल हमने पढ़ा था, यहाँ पर हमने आइसोलेटेड फुटिंग दी है, इसको हम स्ट्रेप फुटिंग करते तो अच्छा था, या ये सेफ है या इकोनॉमिकल ये है, इसमें अगर आप काइंडली थोड़ा ब्रीफ करें।
देखिए हमने इसलिए सेलेक्ट किया कि हमने जो एट द स्टार्ट हमने जो एरिया फाइंड की थी, फॉर एग्जांपल इफ आई शो यू, कि हमारे पास जो एरिया था वो आपके पास इकोनॉमिकल आ रहा थी 4 फीट 9 इंचेस एंड 3 फीट 9 इंचेस, और उसको हमने इसमें मॉडल कर लिया था, हमारा जो टेप था, तो इसमें काफ़ी इन बीच के दरमियान काफ़ी डिस्टेंस आ रही है, ठीक है। लेकिन अगर अब हम इसको कंबाइन कर लेते हैं तो इस यहाँ पे जो रेनफोर्समेंट आ रही है उसकी ज़रूरत ही नहीं, यहाँ पे फुटिंग की ज़रूरत ही नहीं, तो हम क्यों कंबाइन पे जाए या क्यों स्ट्रिप पे जाए? हमारे पास पंचिंग का कोई इशू नहीं है, राइट। हमें हमारा पंचिंग कंट्रोल है 13, जो हमारे पास 18 इंचेस है उस पर हमारे साथ पंचिंग कंट्रोल हो गया है, तो हम स्टेप फुटिंग पे क्यों जाए, राइट। नेक्स्ट हमारा जो सेशन होगा वो इसी पे है, इसी फुटिंग को हम उठाएंगे और हम उस पर रिस्ट्रिक्शन लगाएंगे कि अगर हमारे पास फुटिंग 12 इंचेस से ज़्यादा हम इसको प्रोवाइड ना करें, या क्लाइंट आपसे कहे या आर्किटेक्ट कहे कि आप 12 इंचेस से ज़्यादा प्रोवाइड नहीं करेंगे, देन यू हैव टू गो टुवर्ड्स द स्टेप फुटिंग। हमारे केस में ऐसा कोई रिस्ट्रिक्शन था ही नहीं, हमारी जो बेरिंग कैपेसिटी थी उसके मुताबिक हमने जो एरिया फाइंड किया वो इकोनॉमिकल है, तो इस वजह से हमने आइसोलेटेड फुटिंग कर ली। अगर हमारी बेरिंग कैपेसिटी इससे कम आ जाए तो फिर ये इसकी जो वेट एंड लेंथ होगी वो ज़्यादा हो जाएगी, तो अगर फॉर एग्जांपल इसकी वेट तो लेंथ यहाँ तक आ जाती है दोनों की, उसमें बीच में फासला 1 फुट रह जाए या इससे कम, then you have to go towards the combined footing to make it economical.
अच्छा सर, ये सिंगल जो आइसोलेटेड फुटिंग है उसमें सिंगल रिइंफोर्समेंट नहीं होती है या डबल भी हो सकती है?
उसमें आपके पास सिंगल तब होगी जब आप उसको ग्रेविटी के लिए डिजाइन करेंगे। फॉर एग्जांपल ये जितने भी इंटीरियर कॉलम्स है, अगर आप इसको सिर्फ ग्रेविटी लोड्स के लिए डिजाइन करें तो इसमें आपके पास टॉप रेनफोर्समेंट नहीं आएगी, सिर्फ बॉटम आएगी। लेकिन अगर आप इसमें अर्थक्वेक इंक्लूड करें तो अर्थक्वेक की वजह से इसमें अनबैलेंस्ड मूवमेंट आ जाती है, जिसकी वजह से टेंशन प्रोड्यूस होगा एट द टॉप ऑफ द फुटिंग। तो फिर आपने टॉप रेनफोर्समेंट ही प्रोवाइड करना है।
ओके सर, थैंक यू।
जी, is there any question? So is there no question? So you can work with this model. I will share the ETAB model and safe model as well with you guys, so you can work and practice on it. And I will share the lecture and recording as well later on, and you can practice. And if there are any questions in this session, you can ask me tomorrow, right? चलिए ठीक है, सेशन एंड करते, कोई क्वेश्चन तो नहीं? All right, so there is no question, so see you tomorrow inshallah.